Okay. Well, let's start with this talk about Redux Saga and then a little bit about Vikings. Well, first of all, thanks to our sponsors for their support. And well, to introduce myself, I'm Nacho Martin. I'm actually from here, from Alicante, well, 50 kilometers from here, actually, from Alcoy, a town. But I live nowadays in Germany. About my background, I started in a different part of the stack, as I started my career as electrical engineer, doing signal processing. Then following the path of projects that were interesting, I moved to the backend. And since the big JavaScript explosion, I became more and more interested in the problems that were in the front end, and also what I consider very elegant solutions to them, like React, which I think is very clean and elegant. I work in a company called Menus, and we do custom tailored projects for customers and trainings, and we are really, really happy with React and React Native. Then let's see, the parts of this talk will be first a discussion, because if you are a beginner with React, you may find that in this kind of conference you see a lot of options, different libraries, and it's not clear sometimes if a particular library is mandatory in every project. So I think it's important to know about the different libraries, so when you have a particular problem, you know which library you may want to study, but it's important also to know that when to use them, and not use them all every time, because they will be very complex. Then we will discuss, because Sagas, when you start with them, they look very like a complex thing and a bit alien. And it's important to know if there's something to say about the theoretical foundation of Sagas that we will discuss. Then we will do an introduction to ES6 generators, which is a feature of ES6 that is not so used as others, not so popular, but is very, very powerful combined with promises for this kind of job. And if you understand generators with promises for this particular case, then Sagas are very easy. If you don't understand this part, then Sagas are very difficult, and you tend to copy-paste from other tutorials because it's not clear. And then we will explain the tools that Sagas give to us. Then the first section, well, maybe you don't need Redux Saga, okay? And maybe you don't need even Redux. Different applications, even of different projects, even if they are complex, they tend to be complex in some areas. Some of them are complex in the styling. You have to deal with themes and so on, others with forms, for instance. And in this case, this solves a very particular problem of orchestrating side effects. And for instance, API calls, talking with the WebSockets. We'll see what this means. But for those of you who are, just to have a common ground, this is the schema of how Redux works. So this is like a circular flow, right? The idea of the circular flow is is the important thing. So a view can dispatch an action, and this action is an object that has a type like a button pressed or something more concrete. And then a reducer takes the current state, the version of the state, and the action, and produces a new version of the state. So in this case, for instance, says button press, so we can maybe display something, and then views that are connected to this change of state, or this part of the state, this slice of the state, will update themselves. And there are another kind of, or another way, or another stuff you might want to do with actions, which involves making, for instance, an API call, or dealing with the real world. So in this case, Redux is open to plug middlewares that deal with this. So maybe, for instance, an action is do an API request, and then middleware captures this, makes a request to the API, gets the result back. Maybe it's a success, maybe it's an error, and then a reducer can update the state. So we can maybe load the post of a user or something like that. Let's see with an example. Maybe we do API request, and then synchronously we process this by a reducer, maybe to display a loader, right? So we say, okay, we're requesting now. This is fast because it's synchronous. But at the same time, we want to do the actual API request. So the middleware also reacts or processes this action, and then does an API call. May take forever, may take 2 seconds, may fail, whatever. But if it's successful, then we dispatch a new action. It's like success, and here is the data. And then the reducer takes the data and produces a new version of the state with the data in there. if it's a failure, if it's an error, then we do the same thing, like we dispatch a different action, and we may display an alert, or yeah, so the views can react to this. So the important thing here is that here in the left side, it's always pure code that has nothing to do, when we say, has nothing to do with the real world. I mean, it's inside of our application, it's not talking to the real world, it's not affecting the real world, and it's not affected by the real world. Well, in theory, unless there is an earthquake or something like that, it's affected. But then we have this side, which deals with side effects, dealing with the real world, right? So in this talk, we'll see how Sagas are used to isolate our side effects in this layer. So if you look in the documentation of Redux, or you start using Redux, you will see that there is a library for this, created by the same creator of Redux, which is called Redux Saga. And Redux Saga does something like this. In the action creators, instead of returning an object, can return a function that can contain promises, they are resolved. So this will do the same as we described. We dispatch synchronously, sandwich request, and then with the promise, when it's resolved, success or error, we dispatch at the time actions. So if you only want to do this kind of thing, you will be perfectly happy with Redux Saga. Many applications just want to do this kind of API request, and that's it. So you don't need to deal with something much more complex, because Redux Saga has a very nice property, which is only 14 lines of code. So if you have a dependency that you can like read in minutes, I think this has a great value. In the opposite case, Sagas are like thousands of lines of code, and it's very likely you don't read them all. So, but what if you do? What if you have more complex side effects to do? We will see examples of this. In these cases, you have several options. The most popular are Sagas and observables. There are two different styles of doing this. I'm going to talk about Sagas, which is a topic big enough. And I don't think the humanity has solved this forever. Maybe in some years they will become, or maybe it exists now, but I don't know, something better, or we say, okay, this is super, super fine. But I can tell you, both of them, and especially Sagas, which is what I use, are very, very nice solutions for this. Then, let's see about the theoretical foundation of Sagas. Because Sagas happens to be, as I have been struggling with understanding the foundation of Sagas, is a word that attracts mutations from humans. Humans like this word, and to change it and dilute this word, like they really want to smash it. So it's not only in computer science, but the original word, Sagas, has very, very particular meaning. Originally, it's about Viking kings. It's a form of literature in Iceland about Viking kings in very specific period. And typically, there is a Viking king who is a bit bored, and then they build ships to find new places, and then they talk briefly with the locals, and then, well, they sometimes kill the locals. And this has very, very particular meaning in in literature, it's super specific. But then, with time, after 8 centuries, I think, now you can say something like, my neighbor told me the saga of his divorce again, which is something that a Viking will never understand. Okay, so we just diluted this until it means a complicated story with many details. And then this happens as well in computer science. Because if you see the very documentation of Redux Sagas, and you go to the second section, they say, read this paper. Like, there's a link of the paper of Sagas. And I was like, I'm playing with Sagas, I'm doing something, but I want to read the paper, like, to know what this is about. And you look the paper, you look the author, and the author looks like he's quite famous, has a Wikipedia article, so I was reading about him. Hector Garcia Molina, he's from Mexico, but he's a professor in Stanford, and has a lot of facts, like he's the fastest typist with 2 fingers, they said. It's in Wikipedia, and also, I was like quite impressed because he is the mentor, one of the mentors of Sergey Brin, so I was like, okay, I'm reading the paper, 1984, and I'm drinking from the same source of Sergey Brin, this must be the right path, and also I'm learning to use Sagas, which is what I have to do for my work. So I was like very, very interested in this, and well, academic papers are hard to understand, but so do the cipher. So I get that it was about multiple workflows and compensation actions, and as I read more and more about this, I felt more and more stupid, because it has nothing to do with the Redux Saga at all. And I was like, what's happening here? And it happens that in 30 years, because computer science goes faster, we have diluted the word totally, And I guess people are just saying, okay, this project is Sagas, then my project is also Sagas, then my project is also Sagas. And nowadays, it means a process manager used to orchestrate complex operations, but nothing to do with distributed computing. Or if you look, for instance, there are videos, super interesting videos. Like if you look for Sagas, there is a video of the developers of the Halo video game, where they speak how to solve a very cool problem with Sagas, but this Sagas had nothing to do with Redux Sagas. So it's just super confusing. So, and in Redux Saga, just means library to manage side effects. So this is a dead end unless you are super curious about this. Then, what should we do to really understand Sagas? Well, the fundamental thing you need is to understand really well generators and how to combine generators with promises. It's not so common. I mean, I don't think it's so useful that people have knowledge of good knowledge of generators. It's not one of the most used features of ES6, but they are very powerful. In case you don't know, if you see this function asterisk, it's not a mistake, it's not a footnote, it's the syntax for generators. So let's see a first generator. A generator has, I'm going to take some time with this because if you know this, it's like, I think 60% of knowing how to work with Sagas or maybe more. So this is a generator with the function asterisk, and they are used to build iterators, to build sequences, okay? And the interesting thing is that we can control their flow from another piece of code. So in all these slides, we will have in the left side, the generator, and in the right side, a runner, something that is running, a code that is running the generator. Okay, and so let's have this generator, which has like kind of 3 returns, so it's our yield, so how they work. We just call the generator, and we get an iterator, right? If we do, then we debug this iterator, we will see in console log an object with no 1, no 2, no 3, but some methods we can call. And the interesting method is here is next. Next has very specific rules. It means the code is post. I mean, has not run this yield 1, 2, 3. It's just post at the beginning, and next will say when I call next, the code will run until the next yield, and it will return whatever is in the right side of the yield. So this console log will be 1, and also some metadata like I'm not done. I think I'm not done. I mean, the sequence goes on. I'm not finished. And then you call it again. Next, we'll make the code run until here, and it's paused. So you get 2, and I'm not done. Same, 3, and I'm not done because it doesn't know if there are more things in there. I mean, because it can be more complex, like in a loop or whatever. But then if we call it a 4th time, we'll see value undefined and done true. So we have generated 1, 2, 3, which is a stupid case, but it's a first case. Then we can do another thing to control the flow even more. We can inject values, parameters, in the generator while it's running. So we can control how it's running, and then we can inject things as we want. In this case, we are going to build an iterator that adds up whatever we pass to it. So it has also very specific rules. The parameter will substitute the yield we are post on. So this first parameter will go directly to the Valhalla, will not be used because we are not in a yield statement, right? But then next, we'll go to the yield, and if we do console log here, we'll see first value is 0. Then if we do it again, then this 1 will substitute the yield we are currently on. So this order is important because when you are testing generators, it's important because otherwise it's like, I don't know what's going on, what's the order. So 1 will substitute this, now x is 1, we console log, and then we get second is 1, we do it again, this 20 substitutes this yield, and then it runs until the yield. No, sorry, yeah, now x is 21, now it runs until the yield, its post is here, and we get the value 21. And finally, the same, 300 substitutes this yield statement, we get x is 21 plus 300, 321. Then this is more interesting when we generate infinite sequences, right? Not only, it's like we are writing the sequence ourselves here. So we can do the same for infinite sequences. It's just a loop. This is more difficult to follow because it's always the same yield, so you have to think mentally, like, where I am in which iteration, but it's the same. So the first one goes off, then we have 1, 21, 321, and let's go, and we continue. This has very interesting consequences, a lot of things we can do with this, but the case we really want to explore is how to combine this with promises. So this will be the most complex example we will see, I promise. Then, here we have a generator that will yield, instead of a value, a promise. So our runner will take care of all the logic, of all the JavaScript logic of dealing with callbacks and so on. And the goal here is that the generator is super readable. And we can write async code as if it was synchronous. So the first value we get is the promise. So it's promise pending. No? The promise has 4 seconds to run. And then, so we can say when the promise is resolves, then we can get the result. So 4 seconds later, we get the result. What we can do now is to inject this value back into the generator. So it will substitute the yield, and we get the user. So from our point of view, as writers of the generator, we are only writing our logic, not dealing with the promises and so on. So if we wanted to do a more complex example, will be something like this. And this is very readable. I mean, we are not dealing with callbacks, nesting, and so on. So we are fetching a user, doing some crypto, setting a session, fetching posts, and we get the result, and so on. And this will take the time that it needs, but we can just read it. So with the time, what we have achieved with this technique is that we are doing asynchronous code as if it was sync, and it's easy to understand, and all the things we are writing here are the things that describe our business, that describe the problem we want to solve. And all the things that we have to do in JavaScript to do this, all the callbacks, which is quite difficult and don't map well with our brain, will be here. So this code, as you can imagine, in this case will be quite difficult to write. But the nice thing is that it has nothing to do with our user or posts or whatever, and it's totally reusable between projects. So instead of writing our own runner, we can just use a library. And one of the libraries that is here and provides us with helpers for dealing with Redux and so on is Saga. So they are written, this super complex library, so you can write this easy to follow or readable code. So now with this, we can see Sagas in itself, right? So let's see first how to tell Redux that we are using a Saga. If you are using Redux, you will see it's always the same. So you have to create a store, and in the store you say I'm going to apply the middleware. You can apply many middlewares, and in this case we say we are going to use Sagas. And to Sagas, we tell them, and please run this generator, this Saga. And this Saga is written by us. We can only pass one Saga. It will be like the root Saga. We will say later we can have children and complex structures of Sagas. But yeah. Yeah, so we pass this generator, right? So let's see an example of how to use this. The simplest I could came up of side effect will be how to play a sound. I'm going to use examples of games, because games are simple enough projects to follow, with not invoicing or whatever, but they tend to be very complex in the terms of side effects with WebSockets, playing sounds, a lot of cancellation and stuff like that. So imagine we have a class named Sound Manager, and we can start it, like set it up, like load these sounds, and then we can play sounds by passing the string, like this is a game of chess, online chess. Then when the player moves, we want to do like clack or whatever, ring. Then how can we use this in React, right? So there are many options, but let's just assume we want just to go ahead and code. So we may think, okay, you have a button, so I just call Sound Manager and play this buzz. But then where does Sound Manager come from? Where it's not evident. The component, how has it access? So we think more. We say, well, let's use Redux for this, just dispatch an action which is play sound. But then this play sound must have access to Sound Manager. It's not so evident. Okay. Then what about we pass Sound Manager to the root component, and then it will propagate, will pass as props to children and children and children, and every component in the application now has to play a sound. well, maybe it works for one thing, but it's like you have a menu and it's aware of sounds. It's quite horrible. And then, so we try to find something better. So we think maybe we put this in Redux, in store, but then we are kind of breaking Redux because it's not serializable, so we break, maybe it works for you, but if you use another external library, I mean, you are breaking Redux here. Breaks time travel, persist, rate rate, I mean, breaks the assumptions of Redux. Or you can think, maybe use context and I be like a provider, like Redux does. I mean, this can work as well. And you say, okay, I think I fixed it more or less. Well, yeah, I can now do that. Or there are other, of course, Sagas is not the only option. There are more clever solutions to this. But I mean, it's not like the most trivial thing you can do, even to play a sound. But in this case, for instance, we do that, and when I do these kind of things that I'm not happy, I feel like in 20 minutes something bad will happen to me. And in this case, you read this next ticket you have to do is like, so okay, when the opponent moves and we receive the movements from a WebSocket connection, then we have also to play a sound. And then, okay, now again. Then when I mount the game, then I will connect a socket and pass the sound manager to it. But it reads very weird, right? Like connect a socket, you should pass like a URL, something that has to do with connections. Sounds and WebSockets have nothing to do. It's just because we don't know anything better. And also, what happens if the socket is already connected and we just want to start listening to new events? It's not so simple. Then, well, there are, of course, many options for this, but let's see how to do this in Sagas, right? So Sagas, we can import a lot of effects to like helpers. And one of the most used is take an action. So it will block until it receives the action, play sound request. And then we can, for instance, say, okay, I want to debug that this is working, and we try and works. And we can, then next thing we do is when I build the Redux Saga, I pass the sound manager. And this is perfectly okay because Sagas is dealing with side effects, and this is dealing with side effects as well, so we're kind of isolating the side effects here. So now we can do this, take the action, and then we play the sound. This is nice, but it's difficult to test because you have to mock the sound manager. This is, by the way, the reason they don't use async await, because they use declarative actions. What does it mean? Declarative effects. So we use here something called call, which does the same. It will call a function and it will block until it's done, or can call a generator to do more complex stuff. And if you want to see what is the result of call, you will see that it's an object. It's a declaration of what they want to do. Like in React, many things are declarative. Sagas are also declarative. They are declaring what I want to do, and then Sagas will do the hard work of really doing it. So testing a Saga is as easy as testing that the result is the object I want to see. Now that the tests are meaningful, that's something up to you, but testing this thing is testing objects. So not testing actual calls to mocks or something like that. Let's see more effects. This is kind of a collection of effects. No, sorry. Yeah, now we have this. The problem is you can only play one sound and terminate. It's only one. So what happens if we want to play infinite sounds? We know we can generate this infinite sequence while true. In this case, while true, which is something you shouldn't use outside of generators, doesn't matter because we are controlling the flow from the outside. So it's not like it will suck the CPU forever because we are taking control from the runner. So it's perfectly acceptable in generators. So in this case, it will just play, will take every action and play a sound, right? Then, let's see more. As this is super useful, this kind of pattern, this while true, I do this, you can use take every. Take every is this pattern. Well, it's a slightly different pattern. We will see exactly what this means, but it's used for the same. Every action will run this, execute, call this, in fact, fork this. Then another one, put. Maybe we want to say when the user is logged, I want to dispatch a new action. So it's this with put. We will do this with put, dispatching new actions from Sagas. You see, it's quite readable. Login, and then fetch new messages, then whatever. With this, now we can really do an AJAX request. So if you remember thanks, it's something like this. Now you see the same example in Sagas is this. So we are not having a great gain. So that's what I said. I mean, it's not shorter, not much more readable. So if you are only doing this kind of job, why to use Sagas? No, it's nonsense. Or maybe, well, if you like them. So we can, in this case, take every action and, well, put dispatch an action to show the loader, and then asynchronously fetch a URL, and then dispatch the action success or error. Is the same. But what happens if we want to do something more complex? In this case, in Thanks, we should have to do a nesting of promises or something like that. For instance, take latest is one-liner that is much more easy. It is much easier than using building yourself, for instance. This take latest only will take into account the latest task that we do. So, for instance, we have an autocomplete form, and we have Hector Garcia Molina, which is typing super fast. And we don't know if the server will send us the responses in the same order that we did the requests, because some of them take more time and so on. So we want to be sure that the latest thing Hector typed is the one has effect. So we can use just this thing, and this is because this deals with cancellation of the previous task and so on. This kind of helpers, and it's very easy to read. Okay, so we ensure that only the last phase data will be running. Then we have things like forks for having children. We can, for instance, have a sub-saga that deals with the sequence of a game, playing sounds, watching if the user leaves, things like that, or yeah, whatever in the inner game. And we only want to launch all this saga when we receive the action join game. So we do this. And this opens the door also for, fork will create, a task without blocking. Call is more or less the same, but it will block. So in this case, we can just, in parallel, launch many children. Like I described these other things I want to do. Sub-saga, sub-children. So now we can also cancel, because we can store a reference to the game saga, which is this one. Okay, we store a reference called game saga, and then we can have another saga that receives the reference of the first one. So in a chess game, in case you play online chess, people are assholes. Like, you are maybe winning, and the other guy, instead of surrendering, he just leaves. Okay, he just leaves you like waiting, like until the time is out. So as a programmers, we can have the responsibility to support assholes. And then, if he just leaves, we have to cancel all the sagas that are watching for playing sounds or whatever, reacting to the things that are in the game. And we have to say, okay, you are, well, okay, but now you have, even now, you have a clean application for you. So it will cancel the other saga, and we can receive here, we can check if we are being canceled, so we can do some cleanup in the brother, the sibling. Then we have forks, and we have also an option, different option, which is spawn. So it's like, this is parent and children, so you can think of a very well-structured family or a very disastructured family. In fork, a parent waits for children to terminate. If a children has a problem, an error, and it's not caught, the error will bubble, so the parent will also receive the error. If you cancel a parent, it will cancel automatically all its children, so it has many uses, but maybe sometimes you want them to be totally isolated. So in spawn, they are detached, they don't bubble, the errors don't bubble up, but you have to kill them manually, okay, because the parents don't care about their children in this case, right? So different problems have different solutions. Now we have seen some effects. We'll see that some of the effects are constructed as a combination or sequences of simpler effects. For instance, take every is using fork and take, right? So you can build your own effects if you find a pattern that you want to follow. Then there are more stuff. For instance, you can do things for concurrency in like all of these. I want to launch all of these children, and I will block until all of them terminate. Or you can do a race, which means the first one who is done will cancel all its siblings, which are in progress. For instance, in a game of chess, you are playing with the artificial intelligence, and we leave the artificial intelligence like 10 minutes to find the best move. And these systems normally work. They have like the best system, the best movement so far, but I'm exploring more if I find better. So they have like kind of the best until now movement. So we can do arrays and say, okay, in calculating this, if it's done, but I also providing a button to the user, so give me the best thing you have now, computer. And then, so if the user presses this button, the other one is canceled, and we can, in the cleanup, give the best movement so far. There is this typical pattern, is take and then fork, like listen and then do something. But sometimes we want to do things sequentially, like we wait until the task is done to process more actions. In this case, we want to kind of buffer, or we want to kind of buffer, for instance, when we're doing something with WebSockets, like the WebSocket is down, but we still are receiving actions. So from the user, and like for instance, Google Docs, connection is lost, but when the connection is resumed, you don't have to type the paragraph again. It will just, it's buffered somehow. So for these cases, you can use channels. Channels will be kind of a tube, and then you can consume from this tube, like a queue. So we take from the channel, and then we buffer. It's not super important to understand every one of them, but like to have an idea of which kind of things you can solve, or in case you have a problem, maybe Sagas are the right movement or not. Then an advanced thing you can do is you can say, for instance, now WebSockets are emitters of actions, like my components in React that are dispatching actions. So WebSockets, I can use this event channel. I put here a URL, which a nice, very nice blog post about this. So WebSockets now are producers of dispatchers of actions, like a source of actions in your application. I will upload the slides, but if you want. Then, and the last one, because there are like, as you see, as a collection of tools, sometimes you are forced to, or the only thing you can think of, or the only solution for your problem is to check out the state in the store. It's something that you should avoid. I mean, if there is another option, but you still can. You can select the state, and then based on the state you have, you dispatch an action, don't dispatch an action, cancel something, or whatever. So select task gives the state after, or the reducers, you have to take care of this, but it's still possible, right? So, and with this, we've seen summary of different effects. So you can think, if you have a problem, how to model them in your application, right? Which ones should I use? Which ones are, for instance, I don't use spawn in my projects. I never used it, or I never use raise, but I think I have a good use now. But the others, for instance, yeah, you kind of find, it's important to think, I have this problem, I can model this with this or not. Then, to summarize the talk, don't use Sagas unless you have to orchestrate complex side effects, but prepare for that moment. Instead of doing super callback of promises, and then finding and spending days trying to force this or bend this code, or thinking your super clever solution of this, you may think, okay, now is maybe the time to learn Sagas or observables of some tool that is available. But until that moment, you don't need Sagas. Then forget about the Sagas papers unless you are super curious, like very curious about distributed computing. But instead, go into generators. Generators are very, very nice way to solve these kind of problems. Since I work with Sagas, I explore this generators thing. I'm using them for other stuff, like not only for this, I use particularly for animations and things like that are synchronous as well. Usually the same pattern, so you can use it. Then think out how to model your problem with the effects that are available in Sagas. Here I gave a list, but the list is not exhaustive. There are more stuff. You can know how to throttle, the bounds, patterns that are composed, whatever. But yeah, so that's it. If you have questions or.
Hello. So basically, I have a question regarding Redux forms and Eric's presentation yesterday.
Okay.
So is it Redux Saga the proper place to dispatch actions about Redux forms? For example, if I want to clear a form to initialize it again or something like that, or could it be that it's an overkill to put it there?
Well, you can dispatch whatever action you need. From my understanding from Redux forms, you should avoid calling the actions directly, although you can in some cases or not. It's better if Eric answers, because I think it's more related to Redux forms. It's something I would personally do. So
that you can dispatch actions. We export all of the actions that you can dispatch.
Yeah, yeah.
Specifically for this reason, because people said, I want to use Redux Saga to be dispatching stuff. And so you can totally take complete control away. Redux form handles promises when you're submitting, and then there's promises, but you don't necessarily have to return a promise from your submission. You can handle it all in Sagas if you want to.
Okay.
Okay. I have a question.
Okay.
I have the microphone. So generators came before async and await to JavaScript, and they feel very similar. Why would I use generators now that I have async and await?
Okay, yeah, there's like the super long discussion in Sagas about this. Because of course this is like,
I'm sure there is, yes.
I mean,
I haven't read it, so that's why I'm asking you.
Yeah, so the thing the thing is that they consider that with the, well, first they provide effects that they could use even if they was I think await. So it's like one profit you take from Sagas. But then the thing is that at least from their point of view, because they can do this declarative action effects better with the generators, because they have this so is this better for testing? It's for testing reasons, for for being more clear in the tests. So that's the reason. And as you are writing, normally generators with promises is more annoying to write because you have to write the runner. But in this case, as the runner is written for you, you have only to focus in generators. I don't see a lot of difference from the user point of view, writing generators or writing async await. So maybe we'll simplify their life, but for the user, yes.
Okay, that's good enough.
So you mentioned testing a couple of times. Did you ever feel that testing Redux Saga is just like copying the code line by line?
Yeah, that's what they said. Now, coming with meaningful tests, it's up to you. I mean, at least you don't have to mock. Yeah, but you have to really think about the testing. What is the purpose of your test? Because it makes it very easy to check that the calls are the real calls you want to do. But yeah, you can end up, if you want, like, I want 100% code coverage, and I just want this code coverage without thinking about what I'm testing, or without thinking really hard, because sometimes it's difficult. It's possible that you end up just copying the Saga in a test, because it's like, I write the Saga, which is a declaration of what I want to do, and then I check that the declaration is well written, which is the same. But it's up to the user. When I talk with people with observables, they say that it's also difficult to, I'm not used to observables so much, but they say it's also difficult to find meaningful tests with observables. So that's what I consider, that maybe there will be another solution, maybe, but we are talking about meaningful tests, kind of. The libraries are very good, but yeah, I have a problem because it's difficult to convey the meaning of the contract. So it's up to the user. It's not everything.
Thank you. That's great that you touched that point. So at the beginning you said about Sagas and observables.
Yeah.
I have exactly this situation now when I need to choose. And my company already chose Sagas, but for me, somehow observables feels easier. So I'm trying to find arguments to choose one or the other.
Yeah.
And testing was exactly the argument that was written everywhere. So you cannot actually find tests for observables. At least I cannot think of any. And you can test Sagas. Can you maybe you know something else that makes the difference between Sagas and observables? So maybe you can simplify my choice.
The problem here is that with many stuff you can try, you can do a project in a weekend and then have a taste of how it looks. But with these things, you need a complex enough project. So you need really, I have a real problem with real cases, like some of you, I was speaking downstairs with someone that had a real problem of maps and some stuff that is not evident that you will find it, So if you are just pressing a button and so on, you can have a taste, but I think you have the idea of if it's good or not when you are really solve a complex problem for maybe months. Then in that case, at least in my case, when I invested my time in learning Sagas until the time I'm proficient in my projects, there is not a big incentive for me to start this just for the sake of trying in a new project that will take months for a client, because it will be like, I want to learn observable, so we will going to take 2 more weeks for my train. And you understand me? So I will maybe will have to take several weekends in doing a game of chess. It's difficult to have the experience in 2 complex projects and the motivation to relearn again. So in my case, I cannot tell you because I know something about observables, but not enough to say I solved the same problem, which was complex in both libraries, and I thought this was better. I just play with observables, and I think they are nice, but my experience is in Sagas, so.
Great, thank you so much.
Any more questions? Thank you.